right. Hi, my name is Kell. I work with NetSpy. Yeah, this talk started as a learning project a couple years ago when I was trying to get into mobile application testing, and it's kind of morphed into, I've been down this embedded systems rabbit hole the last couple of weeks as well. So it's the project that keeps on giving. Just to give you guys some structure, the project was 3 phases. The first 2 phases I did back over holiday break in 2022. It sat on the shelf, sadly, for a couple years, and then when I proposed it for this talk, I went through phase 3. And it was interesting, like, being able to take a learning project and go back to it with some of the mobile skills that I developed since then, and to take another look at things. So if you have a project like this that you've been, sitting on the shelf for a while, it's a good idea to pick it back up when you've got a little bit more tools in your toolbox, as it were. Also, thank you very much, Carl, for helping me out with my presentation. All right, so back in 2021, we wanted to take a little bit more of our workouts at home. I wanted to get a rowing machine. My wife was okay with it, but she insisted that it had to be a smart rowing machine. So in short, it's an Android-powered user interface. It has some gamified workout experiences that are locked behind a paywall. It's usable without a subscription, but there's something about seeing that little meteor ball like bounce as you're doing your rows that it is kind of motivating. And when I canceled my subscription, it was something that I kept taking a look at, and since I'm a cybersecurity professional, I decided to take a deeper look at the unit, as it were. So we enter phase 1, proxying and manipulating traffic. So the goal here is to try to identify what traffic is it sending, how is it handling authorizations, can I even proxy the traffic, and what happens when I manipulate those responses before they get back to the rowing machine. So talking about scope, the API on the back end is strictly off limits. I'm manipulating responses coming into the rowing machine and only sticking within my own network. So the lay of the land is it auto loads this app on startup. It goes through a setup sequence. The app loads. You're inside the app into this splash screen here. And can you guys see my cursor okay? I just want to make sure. There's no virtual or physical buttons. So like when you look at the thing, there's nothing to push or prod or anything no seemingly way to navigate away from the application. The locks here that you see on the screen, those are subscriber features that are behind the paywall. And I ran an Nmap port scan to see if there was anything interesting that I could enumerate there, and it reported that all the ports were closed. But on the back, there's a lot of ports on the back. And so you see these SD card ports. There's a USB-A port here, the serial port that I enumerate later in the presentation. And so, of course, what do? I plug in my micro USB adapter here so that I can connect it to my testing machine. And this dongle here is a wireless keyboard dongle, and that one was the trick. For those of you viewing at home, you heard a chime sound. That's the chime that I hear whenever I connect my USB dongle. And I knew that I was able to do something interesting. And so using that wireless keyboard dongle, you can Alt-Tab away from the application. And this is going to be like a big Jedi hand wave over this, but the objective is to enable USB debugging so that I can issue Android debug bridge commands, or ADB, from my testing machine. And then I can start changing like Wi-Fi configurations and all that. So the next step when you're trying to proxy traffic from an Android-enabled device is to get my CA cert, my certificate authority cert, from my intercepting proxy into the system store on the device so that I can look at the HTTPS traffic that's being sent. So the first things first, I use burp, so all of my intercepting proxy directions are going to be in burp. You can use zap or any other intercepting proxy. But you need to do this import-export CA certificate from your proxy listeners in burp and export it in the dir format. And then using that, you're going to run this this one-liner here. I got this one-liner from Midem Proxy. It's a spoiler for later on in the presentation, but it's a really handy command because basically what you have to do is you have to take your CA cert, you have to rename it to be the hash value of that cert before it gets into the system store. Otherwise, the Android operating system is going to disregard it. So doing that, you get this value here. So that's my rename cert. Next, what you're going to do is use the Android debug bridge. You're going to restart it as root. You're going to remount the system directory with just this remount command so that it's writable. And then you're going to push your rename cert into that directory, which is listed out here. It's a kcerts directory in security. Then what you need to do is you need to change the permissions on that cert. Otherwise, again, Android's going to disregard it if it doesn't have the right permissions. And then you're going to reboot the device. And then on the device, when you look in the trusted credential section, in the system section, you're going to see this Portswigger cert. Portswigger are the folks that make Burp Suite. So once you see that, you know that you should be able to proxy traffic. Now, people that are more familiar with mobile testing, especially on the Android side, you might be saying that, wait, you can't just remount system to be writable. That's not possible in current versions of Android, and you would be correct. But I'm not dealing with the current version of Android. So from Android 10 and on, now this is a part that I want to talk about because from Android 10 and on, you can't remount system to be writable. So how would you go about this? You would have to either rebundle the application to have your certificate authority bundled in the application so that the application trusts the certificate that you're providing it, which is a problem here because there's a service running on the Rudder machine that's above root level that whenever I uninstall the APK or the Android application, it automatically reinstalls its own copy. So I can't rebundle the application. Further, the other way you would go about this is installing Magisk, which is a mobile standard for rooting your Android phone. That was a problem here because when I go through the install process, one of the things you have to do is you have to pull the firmware image, modify it, and then get it reloaded onto your device. And when I did that, you enter a mode called fast boot where you can flash the modified boot image. There was about 15 minutes where I thought I bricked the thing, which is a problem when your primary stakeholder really likes using the Rudder device. So it was a hard stopping minute, but thankfully I didn't have to worry about all that. All right, so you have the CA cert installed in the Android Rudder device, and now you have to configure your proxy listener. So in your proxy listener, you're going to edit one of these configurations, create a new one, and you want to set it to listen on the local interface for connections. And you can change this bind port. Usually when I'm using like a mobile test, I'm testing on iOS and Android, so I set them up to listen on different ports so I can more easily like isolate the traffic coming from whichever device. On the device in question, so the Rudder, edit the proxy host name and the proxy port to point to my proxy listener so that it's sending its traffic to my proxy listener for capture. And then going back to my intercepting proxy, you boot up the Rudder and you check the traffic, and if you don't get any errors and you get traffic coming through, great. Now we can analyze traffic. That's a big step in the right direction. Hooray! All right, so looking at the traffic here. So these two requests here, these accounts requests, those are interesting because there's one for features flag and there's one for just my regular account information. So the one for my regular account information, it's pulling down all of my user data, including this billing state, and it says canceled. That's always interesting. So what do? We capture it with our intercepting proxy and we modify it before it comes back to the rowing machine to be active. And when you go into the rowing machine, you don't have any locks in your interface anymore. Okay, so looking at it, I assumed that it was an authorization issue based on just that flag, and it is. But the problem comes in because the workout data that's being used to populate all of these programs is being sent to everybody regardless of what their subscriber state is. So the only thing me changing that flag did was enable my rower to be able to consume that data in these programs and allow me to use the programs. So one feature flag was being relied on to basically paywall all the subscriber features, and when you bypass it, you still get to use a rower as normal. All right, so what about that other one, the feature flags? Okay, so looking at the response, you see all of these Boolean values, false, 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 true. Okay, well, what happens when we turn them all true, 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 before it gets back? And you note that, the one marking here is you can see the editor response. I didn't point that out before. And then you go into the user interface, and I've got this new experimental feature flag thing here. Now, out of respect, I'm not going to talk about anything that I saw in there. I saw some things that are not available for public consumption, and it also gave me access to canary builds if I wanted to download like a beta version of the application before it's released to the public. Well, that's interesting. Now, those account flags are sent several times as you navigate through the user interface and you use the rower for normal functions. So we enter phase 2, automation. So the rower goes through it several times, like I mentioned. Now, is there a good way to automate this? And the short answer is yes. So we enter minimum proxy. What is minimum proxy? It's another intersecting proxy, much like burp, but it's lightweight, open source, and it runs really well from the command line. It's also expandable with add-ons that are written in Python. So anything that you can do in Python, you can write an add-on for minimum proxy to change its behavior and to take actions automatically based on events. Minimum proxy views the request and response as a flow. So each flow is an object, and each object has different attributes. So I was worried about this, by the way. Originally when I made the slide, it was dark text on a dark background, and then I did a lunch and learn, and now it's all this white space with light text on a light background. So hopefully this comes across okay. So this is the basic structure of an add-on in minimum proxy. So you're going to import from the minimum proxy library this HTTP class, base class, which lets you create your own class. So you create a class, change some traffic, and then each flow object, like I said, has different properties. So here you see this flow.request.host. So when we have a host in the flow match our target host, we can do some code in response. So it's an event trigger. There's also similarly on a request, you can do much the same thing. Now there's a whole list of these event triggers, and you can key off on requests or errors or whatever. The other thing that you can do with these is you can do matches based on the path. So if there's a path that comes through that you're targeting, then you can serve up your own response. Okay, so getting into, when I was diving into this, I'm like, okay, I want to be able to see the traffic that's going from minimum proxy down into my rower machine, right? And so I have a proxy chain set up. So I have the rower machine, which is pointed at Burp Suite, which is pointed at minimum proxy, and then out to the internet, because I want to see the traffic that minimum proxy is modifying before it gets back to the rowing machine. So that was the objective here. I guess talking about that, it's important to know what your tools are doing and how they're doing them. That's my main focus here. All right, so burp upstream proxy settings. Now, in the upstream proxy servers, you can set up rules based on, host names in the URL and where the traffic is going. So like, for example, if you need your authentication request to go to a specific host, you could set up a rule that if the host matches this domain, send it off to this host, but I actually want all the other traffic to go over here. And so for this, it's much easier. You just set up the destination host. It's like any traffic going out, I want it to go to my minimum proxy. Now, this wildcard is important. If you ever set up multiples of these rules and you have a wildcard set up, it runs in a stack, a cascading stack, so it starts at the top, it works its way down. Wherever that wildcard is, if you have rules after that, they're never going to execute. So just keep that in mind. All right, so this was my first minimum proxy add-on script. I'm operating on the response. So when the response comes back, if the flow request.host matches my target host name, do some regex matching on the path. Here's a flow.request.path. And if it matches one of my target paths, then what we're going to do is we're going to open a file that has the JSON body that I would like to inject. And then I'm going to modify that response body with my modified response and print a statement saying that something's been modified. It's not really like beautiful Python code, but keep in mind this was 2022. This was a couple years ago. So the response bodies that I have saved look like this. It's just JSON. And so I just save them in the file, ready for use. All right, so then we do a test run. And it works. So on the left here, this is the output for minimum proxy. And you can see here on this request, it does this change billing value. And then there's a little cursor here. If you click into the request, you can see what the response body is. And I was looking for like an indicator. It would be nice if minimum proxy like told you that it modified a response, but you can see here that it's set to active. And then going into burp to confirm. So we've got the request here, we've got the response. There's no edited marking on the response, which is what I wanted to point out here, and the billing state is set to active. So just confirming that everything works as documented. All right, great. Then we enter phase 3. So minimum proxy has an example that states that when you use it, it doesn't send any data to the server at all. And so what it's going to do is modify the response and send it back without releasing it from the internet. So this is important because like the API is out of scope. I want to be persistent in the sense that like the things that I'm changing, like if they make a change to the APK later on down the line, like I'm fine. Like everything that I've done is still going to work the way I wrote it. And so my goal was to confirm that this function worked as intended, create a minimum proxy service running on a Raspberry Pi, so everything's automated, and then eventually flesh out the add-on to handle all of the traffic going to the server. So not just like these member functions, like anything going out would just be handled by the add-on and sent back to the Rudder machine, so it's all kept within network. Basically, I want to decouple the thing from the Wi-Fi network requirement. I don't know. There's just something about something having to be online that, like at first, I don't know. I have thoughts on that I'm not going to get into, and my thoughts and opinions are my own and don't necessarily represent NetSpy's thoughts and opinions. All right, so going back to my proxy map, we're going to flip the proxies now. So we've got the rower pointing at minimum proxy, which is pointing at burp suite, which is pointed to the internet. So this proxy swap is important because I just want to make sure that minimum proxy is not just like making the responses, but still releasing the request to the API. So a pitfall I want to point out, when you have your upstream proxies pointing to each other and you forget to change that setting, what happens is it's an infinite loop of the requests going back and forth, and you start getting like weird behavior in burp, and you don't realize what's going on for maybe a couple hours the first time it happens. But then you check your event log, you've got all these throttling messages, and so that's a good indicator that you've got like the Spider-Man point thing going on. Yeah, I just wanted to mention that. All right. Okay, so we make some updates to the add-on. This is the current state of my add-on actually. So switched up to doing a case statement. So if the flow.request.host matches our target, we're gonna do like a regex search in my local file directory, see if I've got a response already in my file directory that matches the path. And if it does, we're gonna serve up that body in the response, and then we're gonna, write it to the command line. And so then command to run this gets a little bit more complicated with the minimum proxy. So you got minimum proxy in the script, run your script. The mode is you do your mode, and then upstream. And this is pointing at your burp intercepting proxy if you want to capture that traffic. And then you need this SSL insecure flag because unless you port your CA cert into minimum proxy, it's not going to trust the burp cert. All right, so then we run a test, compare the proxy activity. Okay, so on the top here, this is minimum proxy. So you can see that the accounts requests that were in scope, they get logged. It sees the request come in, it logs it. You can get information on that request. But then when you go to burp, this is the same activity. You can see the customer's profile and the calibrated, but there's no accounts requests here at all. So confirming that the documented function works as intended, which is important. So effectively, we can fabricate our own responses in response to requests from the rower. Awesome. Now, I mentioned that there was a cyber squatter or a possible cyber squatter. I think I've since landed on that it's not a cyber squatter. It's actually a legit company. But anyway, so there's these two update domains, right? So there's this rock chip and this local IP address. This local IP address is not on my network. I do not have an IP address like this on my network. I checked. And they're two head requests that never get answered. And it sends out the product, name, the version, the serial number, country code, all that. It's like, okay, that's weird. What is rockchip.com? This is what rockchip.com looks like now. So you can, it's a little suspect. For a long time, I thought it was a malicious domain. I thought it was for sale. But it doesn't necessarily look like a firmware distribution website. Turns out, like based on the website, if it's accurate, it's a rock chip repair shop in Houston, Texas. Now, doing some Google searching on, rock chip. This is rockchips.com now. This is the firmware manufacturer that's in China that made the firmware that is used in my rowing machine. Now, I tried replacing the domain name in the original head request. It didn't pan out, so I was hoping that maybe I could download an updated version of the firmware and maybe install it myself or something or pull it apart, but it didn't work out. All right, so I don't really enjoy my information being sent out into the ether where I don't really have control over it. So I made an update to the code to handle these instances. So now when the request goes out and it matches either the rockchip.com or the IP address and the domain name, I fabricate my own 404 response to get sent back that just says 404 not found. And then now I get responses. Yeah, so it's just like a loose end that I was able to tie up with that. I don't like loose ends very much. All right. So now we can intercept traffic, we can capture traffic, we can modify traffic, we can fabricate responses, and so now we want to be even more automated. So the current state of things is I have to go to the command line or to my intercepting proxy and fire off a one-liner, which is a problem when I have somebody else in my house that wants to use the rower machine as well. So I turn to my Raspberry Pi 4 Model B. So I'm running Ubuntu server headless on it. It's Wi-Fi connected. I can secure shell into it with a certificate, so I can manage it. But the problem is when I go to try to set up minimum proxy as a service, it doesn't run very well as a service. But that's okay because they have minimum dump, which is even more command line than minimum proxy. This is what the output looks like when you're using minimum dump. It works really well as a service. That was another rabbit hole. So I was stuck on this for a couple weeks. So a shout out to Corey Solovowitz for helping me get this configured. I looked at cron jobs and service D, and service D seemed to be the much more friendly automated way to do it. So this is my service D config file for the service that I wanted to create. So basically what you do is you have to add this into the etc systemd system directory. And then the other main point here is this working directory here. That was my main sticking point because when you're trying to pass in a script to a command that you're running as a service, it's not running as your user, it's running as a different system user. And that was my main pitfall because it was run as a service, but then you go to the rowing machine and all of your subscriber features are still locked. And so this was the key to get everything working correctly. And then the exec start fully qualified directories. Yeah, to run this SSL secure. Some of this might not be needed. I was in this really deep like troubleshooting rabbit hole when I was trying to work through this. But this conf directory, this is the default directory where Minim Proxy stores its certs. And so because you have to, similarly to how you did your insert your cert into the system store with your BERT proxy listener, when you're pointing the rower directly at Minim Proxy, you have to repeat the same steps. And so you need to make sure that the certs match. When you run minim dump or minim proxy, if it doesn't find a default a cert already generated in its default cert directory, it's going to generate a new one, and then your rower is not going to trust that CA cert. So you need to make sure that they match. I probably could have explained that better in my slide deck, but it's cool. Now we're going to use system control enable to enable the service on startup so that it starts up automatically when the Raspberry Pi boots. And then here you do you make any changes to any of your services, you have to reload the daemon for systemd, which is the system control command here. Start your service, run a status. Awesome, it's running, active, and enabled. The service is enabled. This one I highlight here because this is the one that determines if it's running on startup or not. And you can see here that it's running, and it shows you the command that it's running. Awesome. You go to the rower, you boot it up. Like, I don't have to execute any command line commands now. It just works. So that gets me into current state. So this is where my Raspberry Pi is now. It's effectively glued to the back of my rower machine. Carl had the idea, like maybe you can run minim dump as a service directly on the rower itself, which would be amazing. That might be a good next stage to the project. It powers up normally. I might have some power warnings. I don't know. I've never hooked up like a monitor up to it to see if there are any weird power warnings. Sometimes you get that with the Raspberry Pis when you're running it off of USB power. It seems to work, so it's fine. Now eventually I'm going to build this SQLite database to handle the data that's coming through. So that the workouts come in as all JSON data. My workout data gets sent out as JSON data, so it'd be nice to implement that in a table. I could either take the responses and save it as each entry into a SQLite database, or go for the straight over-engineered solution and translate all of those data points into tables and columns, which is probably what I should have been working on for the last couple of weeks. But I went down this UART rabbit hole with a serial port. So this is a 4-pin 2mm pitch PH connector that I plugged into the serial port in the back. I was really hoping that I was going to get some kind of like a shell would be nice, or even some debug info, but that port is basically dead. So it pulls up, pulls high, pulls low a couple times, pulls high for a couple of bits, and then it goes low and just stays silent. It's oh. So I found this video on Open Tech Lab. They have a good YouTube video on logic analyzers. And so basically with a logic analyzer, with an intercepting proxy, you're using that to enumerate the traffic that's going back and forth over the web, right? Logic analyzer, it's the same thing. You're just doing it for electrical signals. So I bought a 24 megahertz 8-channel logic analyzer from AliExpress for the list price was $6, and my welcome deal brought it down to $1. And SIGROC seems to be pretty cool so far, and it's open source and free, and they have a driver that supports my 24 megahertz 8-channel $1 analyzer. So that's how I enumerated this port a little bit more. So what I was hoping for was that there was another UART port on the inside that I couldn't get to from the outside, and there is. So when you pull this thing apart, there's a daughter board here on the left, and there's a main board on the right. Now the daughter board, it has these, oh good, you can see that. It has these markings here that determine that it's a UART port. So I was correct, so that serial port is a UART port, it's just dead. So the other UART port is here, where you can't see it. I have another connector comes on Saturday. I'm actually really stoked about this because I hooked a logic analyzer up to this other UART port, and there's all kinds of data coming out of that UART port. I just need a good way to get to it without taking the damn thing apart. So there's some vent holes here, and my new connectors come with pigtails, and so what I'm going to do is plug the connector in here, route the pigtail through those vent holes, and so I have a port on the back of the machine that I can get to, so I can analyze it whenever the hell I want to. Yes. All right. So the authorization issues. So one authorization issue came from the flag. Like any input coming from a device, you should, like if it's coming from a user, which basically my device is a user, it should be distrusted, or at least trust but verify. The other authorization issue was the experimental feature flags. So that brings me to my disclosure schedule. So I did a responsible disclosure. I haven't talked to anything about the company because they're still in their 2-month patching window that they gave me. But on July 19th, I made some LinkedIn contact attempts. I probably sounded like a creepy hacker stalker dude, but I'm just a regular hacker dude. They didn't answer. I called their customer support, and they were receptive, and they wanted me to email them some screenshots of what I captured, and so I fired up Wireshark and captured the domains going out to the firmware update domains and sent them that. I didn't hear anything, and so I emailed on September 20th, and that was the first time I mentioned the authorization issues. On the 23rd, their CTO emailed me back and asked for a few more details, and he offered to set up a Zoom meeting. And so I sent him the info that I had, and then I had the Zoom meeting on the 27th. He was very receptive to the information that I gave him about his authorization issues, and he gave me a 2-month patching window. So that's kind of where I'm at now. I'm waiting for confirmation. If I don't hear anything at the 2 months and 2 weeks mark, I'll probably reach back out for a follow-up. I did offer to test it, being a nice, responsible security researcher. But yeah, that's basically how I took a Rudder machine. I mean, I literally took it apart. I still take it apart. It was a really fun learning project, and it started with learning about mobile security testing and going down that rabbit hole, and it's led to this whole embedded systems rabbit hole. I've also started eyeballing like other IoT things within my house, so I guess in my free time I'm an IoT researcher now. This is new to me. I haven't gotten a lot into the hardware like hacking scenario, but the last 6 months I taught myself how to solder, and I've learned a lot more about these embedded system communication protocols. So it's been fun. Any questions? That's an AI generated image of me going down my UART rabbit hole, by the way.
It sounded like something fun to try with a 2019 Peloton. Yeah, who knows?
Yeah, for sure. Well, I'll tell you though, because it's likely Android based, right? So if you,
I think mine's a 8.
Yeah. So
I think that's the Android on it.
Minimum Proxy's website, they have some really good directions on how to, because the main thing for proxying your traffic is trying to get that cert into the cert store, right? So they have really good directions on, based on what version of Android it is, what steps you have to take to get that cert in there. So Minimum Proxy, like they do a really good job with their documentation. I think they actually, hang on, let me go back. I can take your question while I'm looking for this.
Yeah, mitten proxy and mitten dump are awesome. But my question is, have you tried to search for that actual firmware update server? Maybe use Shodan or something like that, using the flags that you captured. Try to find the actual server and see what was there.
I have not. That's a good call out though. I'll do some more information on that. When I was doing my digging on the, because there's some information on that main board as far as like the device. There's a serial number on there. When I did that, it's something called like an RK3366 or 3399, and it ends up giving me a data sheet for like the actual processor that's being used on the main board. But that's about the extent of my enumeration so far. That's a good thought though. I'm going to be diving into another rabbit hole this weekend, it seems. So I'm really good at like going through one direction on my slide deck and going back the other way. I'm going to find that link though. Here we go. So when you go to Minimum Proxy's website, it's how to install System Trusted CA Android. All right. Well, if there's no more questions, I'll say thank you very much, everybody. I'm honored and humbled to be here.